Welcome back. We're in chapter 14 on acids and bases, and we've reached 14.7, which is on reactions of acids and bases. If you remember that in order to get a hydronium ion, we had to break water up. Water was auto-ionizing, easy for me to say. You can take water and break it apart into a hydrogen proton and a hydroxide ion. So if they break apart, then they can also form back together. And if you have a proton acting with a hydroxide, you end up with water again. So one of the reactions is that you can take an acid and a base and react it together to neutralize it. So instead of a pH of 0 or 1 or a pH of 13 or 14, those two can come together to form a simple neutralized water. In fact, that's what's happening when you have an antacid. If you have stomach acid, where you have a very, very high acid content in your stomach, you can take a base, a chalky base, like an aluminum salt or potassium salt, calcium salt, and neutralize that acid, and you end up with your stomach feeling okay. There's other reactions of acids and bases, and it's actually getting into some of the oxidation reduction reactions that I talked about before, where you're actually not just trading protons but also trading electrons. We'll see that later, but we're just going to go through a few of these reactions. This is actually a pretty easy section. So the first type of reaction that you're going to have is that if you were to put a metal in with an acid, you're going to eat the metal away. And these can be some very dramatic labs, very fun. I've dissolved a pop can in some sulfuric acid and it just eats away like the Wicked Witch of the West. It's really awesome. In the reaction, you're going to produce hydrogen gas. So you're going to make lots and lots of bubbles. So if you were to put a piece of zinc in some hydrochloric acid, it immediately just erupts with bubbles, and those bubbles are hydrogen that you're making. So what's happening is that the hydrogen is being replaced by the potassium. If you remember the situation where you can have the activity series of metals, where one will replace another. This potassium is more reactive than the hydrogen, and so the potassium, it's a single displacement reaction where the potassium is kicking out the hydrogen, and then the hydrogen combines together with itself to make hydrogen gas that goes away as bubbles. So the first thing you remember is that metals will react with acids to form hydrogen bubbles. The other one is carbonates. If you have any kind of limestone or even hydrogen carbonate, which is baking soda, this is the famous fourth grade volcano where you take vinegar and baking soda and it erupts together and gives you carbon dioxide gas. The carbonate will break apart into carbon dioxide. It gives you a salt left over and some water. So this is the second one that I'd like you to know, and that's the carbonates or baking soda, hydrogen carbonates, will react with an acid to produce carbon dioxide gas, some water, and then whatever the remaining salt is. You remember a salt is not just sodium chloride, it's any kind of salt. So you're going to have some kind of a metal like calcium with the chloride that came from the hydrochloric acid, okay, or sodium that comes from the bicarbonate along with chloride to make sodium chloride. And then the last one is the neutralization, where you have a strong acid and a strong base, and you put together, and it's going to essentially do the backwards of what we did when water auto-ionizes, and that's that the proton will go back together with a hydroxide and form water again. So hydrochloric acid, the H will come off of the acid, come back upon react with water to form a hydronium ion and a chlorine, and a sodium chloride will break apart into sodium and hydroxide, and then the sodium chloride will react together, and then these two will react together, and you end up with water. Okay, neutralization, you're always going to end up with water. So the salt plus the acid will the salt and sodium chloride is what you're going to end up making, and then hydrogen hydroxide, and hydrogen hydroxide is just water. So a strong acid and a strong base gives you water with a pH of 7. In a chemical net ionic equation, really all you're doing is you're breaking apart the acid into, if you remember, a strong acid like this will completely dissociate into hydrogen protons and hydroxide ions. Okay, this breaks apart. When they come back together, the hydrogen is going to react with the hydroxide to form water, and the chlorine is going to react with the sodium to form some kind of a salt. So you're going to have a salt plus water. So a neutralization reaction is always going to form water plus some kind of a salt. So if you are balancing an equation for neutralization, you have to remember that in order to neutralize, the hydroxide has to join with a proton to make water. Okay, so for instance, if you've got a magnesium hydroxide and you've got nitric acid here, you need to make a water out of the hydroxide and the hydrogens. Okay, so these two have to be balanced. Remember, this is H2O. So if I've got 2 hydroxides, I'm going to need 2 hydrogens to match with them. So the first step in balancing this is that you're going to look at the hydroxides and the hydrogens and make sure that they're equal numbers. So if I've got 2 of these, I have to have 2 of these to balance. Okay, so the first thing is on the same side, make sure that your hydrogens and your hydroxides are balanced because we're making water out of it. Now you're going to go and say, okay, I've got this much on this side, how much water can I make? So if I have 2 hydrogens and 2 hydroxides, I'm going to make 2 waters. So over here on the other side, I put a 2 to balance with my waters. And then whatever is left over becomes the salt. So I've got 1 magnesium and 1 nitrate. Okay, but I've got 2 nitrates here. And nitrate's -1 and magnesium is +2. So I'm going to have 2 nitrates, and so you're going to end up with a magnesium nitrate. So the first thing you do is you're going to find out hydrogens and hydroxides, make them equal. Then go over and make sure you have the same amount of water on the other side as you do with hydrogens and hydroxides. Then whatever you have left becomes your salt. So here's the last idea, and that's an antacid. If you have stomach acid, you can put a base in your stomach in order to counteract that acid and neutralize it. You're essentially taking stomach acid and turning it into water, which is just your body needs anyway. In the case of, say, like Tums, I think Tums is a calcium salt. Your body needs calcium for its bones anyway, so that's a good nutrient. I think Rolaids might be an aluminum salt. It's no big deal, it just passes. But in any case, Alka-Seltzers, these react. All kinds of Mylanta and milk of magnesia, all these are bases that you're going to put in with your stomach acid that neutralizes the acid. All right, I think an easy lesson, just a couple things to remember. All right, I'll see you in class.